In number 15, we have an expression involving exponents. But notice that we have different bases, numerator and denominator. So in order to use our exponent rules, we want to change to the same base. And we can do this because 9 is equal to 3 squared. So let's rewrite, and we're going to use base 3 in the numerator and denominator. So we're going to rewrite 9 as 3 squared. All right, let's use our exponent rules now. 3 squared to this exponent, 2,500, multiply those exponents, is equal to 3 to the 5,000. 2 times 2,500. And we're going to divide that by 3 to the 4,999. And now we can just subtract exponents. 5,000 minus 4,999, and we get 3 to the 1, or simply 3. All right, in number 16, we have another expression involving exponents. So I think what we'll do is first, before working with these powers of x, we'll change to positive exponents. All right, so we have we'll bring this up to the numerator as x to the 5th, and bring this down to the denominator as x to the 7. And then we can also reduce 4 divided by minus 2 is negative 2. Okay, so we have negative 2. Let me just rewrite this, x to the 5th divided by x to the 7th. And now we'll work with the powers of x, subtracting the exponents. 7 minus 5 is 2. Since we started with the denominator, the result goes in the denominator, so that's going to be x to the 2, or x squared, minus 2 over x squared. In number 17, we're evaluating this expression at the values x equal minus 3 and y equal 2. So that basically means just substitute in. All right, so let's rewrite our expression using parentheses instead of variables. So for 5x, we write 5 times parentheses, divide by 2x minus 7, 2 times parentheses, minus parentheses. So now we have a place to substitute. First of all, the x equal minus 3, that would go here and here. And the y equal 2 goes here. And now we're ready to just continue evaluating. Here we have a minus 15 in the numerator. Here we have minus 6, minus 2, so that's minus 15, divided by negative 8, which is 15 over 8. In number 18, we're subtracting polynomials. So let's first open parentheses. We can drop the first set of parentheses because there's nothing in front. So let's just write 4 x cubed y squared minus 3 x squared y cubed. Now we have to be more careful opening the second set of parentheses. We have to apply this subtraction to all the terms. So it's like multiplying through by minus 1. Okay, so for the first term we have minus 7x squared y cubed. And for the second term we're multiplying minus times plus, that's minus x cubed y squared. And now we want to combine like terms. So here we have x cubed y squared. Here's another one. Here we have like terms. Let's add those. And we get 3x cubed y squared. And here we have x squared y cubed, and here's another x squared y cubed. So let's combine those. Minus 3 minus 7, we have minus 10 x squared y cubed. In number 19, we're multiplying a monomial times a polynomial. And we're going to do this by simply distributing through or multiplying through. So first we're going to multiply minus 3x to the fourth y to the seventh times the first term, 2x to the fifth y. So minus 3 times 2, that's negative 6. Multiply the powers of x, add those exponents, and we get x to the 9. And the powers of y, add the exponents, we get y to the 8th. All right, now the second multiplication, we have minus 3 times minus 4 is positive 12. Powers of x, and you have x to the 4 plus 1, x to the 5. Multiply the powers of y, and we have y to the 7 plus 6, that's y to the 13. In number 20, we're multiplying a binomial times a trinomial. So we'll do this using the distributive law. First we'll multiply through by 3x. Okay, so we have 3x times 2x squared, that's 6x cubed. 3x times minus 5x, that's minus 15x squared. And 3x times 7, that's plus 21x. And next we're going to do the distributive law with the second term, include that subtraction symbol in the multiplication. So we're multiplying through by minus 2. Minus 2 times 2x squared, that's minus 4x squared. And we're going to line that up. Line up like terms, one under the other. Minus 2 times minus 5x, that's plus 10x, and line that up. Minus 2 times 7, that's minus 14, and put that off on the side. Now we add the like terms, add those two columns. First bring down that 6x cubed. Add these two columns, add the coefficients, and we have minus 19x squared. And then add this column, and we have 31x minus 14. In number 21, we have 2x plus 5 in parentheses squared. So we have to realize that that means 2x plus 5 times itself. So write it out. And we see that we're going to do a FOIL multiplication. So first multiply 2x times 2x, and we have 4x squared. Then we're going to multiply the outer terms, and here we have 10x. And the inner terms, and we also have 10x. Combine those, we get 20x. And finally, last times last, that's plus 25. In number 22, we're dividing. So let's write this like a ordinary division, x minus 2 divided into 3x squared minus 5x plus 7. And we start by dividing x into 3x squared, and we get 3x. Now multiply 3x times x minus 2, and we have 3x squared minus 6x. And we subtract the top minus the bottom, and we're going to do this by changing the signs and adding. So this plus gets changed to a minus, this minus to a plus, and now we're ready to add. The first column cancels. In the second column we get just x, and bring down the plus 7. X goes into x one time, plus 1. Multiply 1 times x minus 2. And again, change the signs. Change the signs and add. Okay, this column cancels. In the second column we get 9. And that'll be our remainder. So we have 3x plus 1, remainder 9. In number 23, we're dividing x minus 3 divided into x cubed minus 27. But we have to put in all the powers of x. So we're going to start with x cubed, and since we're missing an x squared, we'll put it in as 0 times x squared. And since we're missing x, we'll put that in as 0 times x, and then minus 27. So now we have all the powers of x: x cubed, x squared, x to the 1, and the constant. And we're ready to divide. Okay, so divide x into x cubed, and we get x squared. Now multiply, we have x cubed minus 3x squared. Change the signs and add. We get 3x squared. Bring down 0x. Okay, bring down 0x. Now divide x into 3x squared. That's plus 3x. Multiply, and we have 3x squared minus 9x. Change signs and add, and we have 9x. Bring down the minus 27. X goes into 9x plus 9 times. Multiply, and we get 9x minus 27. So when we subtract, we get 0. Remainder 0. So that means that x minus 3 goes into x cubed minus 27 evenly. Number 24, we have a FOIL multiplication. So first 7x times 3x, that's 21x squared. Okay, then we're multiplying the outer terms, and we have 35x. Then multiply the inner terms, minus 4 times 3x, we have a minus 12x. All right, these are like terms, so we combine them, and we have a plus 23x. And then multiply last times last, minus 4 times 5, we have minus 20. In number 25, we are going to factor by pulling out the greatest common factor. We always start by looking for a greatest common factor. So in this example, the coefficients 12 and 18 they have a greatest common factor of 6. 6 divides 12 and 6 divides 18, so we'll pull out 6. Then we have the powers of x. Always take the smaller power, that can be pulled out in front, and we have the powers of y. Take the smaller one, y to the 7th. And then z is not a common factor, so we don't pull that out. If we pull out factor 6 from 12, we're left with factor 2. From x to the 5th, pull out x cubed, and we're left with x squared. From y to the 7th, we pull out y to the 7th, and the z is left inside. From 18, we pull out factor 6, we're left with factor 3. The x cubed is pulled out, and from y8, we pull out y to the 7th, and we're left with y. And this can't be factored further. In number 26, we have a quadratic, and notice that c is less than 0. When c is less than 0, that means we're going to use different signs in the parentheses. So let's start by writing out our two sets of parentheses, and we'll fill them in with a plus and a minus. We might change this to a minus plus, but we'll start with plus minus, and we know the signs must be different because c is less than 0. In these two places, first we're going to put 2 factors of 3x squared, so that must be 3xx. That's the only way of breaking that up. All right, next we're going to put, for last and last, we put 2 factors of 8. Okay, so that would be 4 times 2 or 8 times 1, and the order that we place these in makes a difference. I'm not going to go with 8 times 1 because I think that'll give us a middle term that's too big, so I'm going to go with 4 times 2. If I put the 4 here, I'll get a 12x. I think that's also kind of big, so I'm going to put the 4 here. And now we must see if we have the correct middle term. So let's try outer and inner. Here we get 4x. And here we get minus 6x. Add these and we have minus 2x. Now our middle term is plus 2x. We got a minus 2x, so since the sign is different, that means we have to switch these signs. So we're going to make this minus and this plus. So the correct factorization is 3x minus 4, x plus 2. Let's look at number 27. We notice that we have a common factor. Again, always look for a common factor first. So here we have a common factor of x. So let's start by pulling out x. And we're left with x squared minus 4 in parentheses. And we notice that x squared minus 4 can be factored further. This is what we call a difference of 2 squares. X squared, 2 squared. So we factor that as x plus 2, x minus 2. Now let's factor number 28. Again, we do have a common factor. We see 3 as a common factor. Let's pull that out. So is x, and so is y. In parentheses, the 3 and the y were pulled out, and 1x was pulled out. So here we have x squared. And for the second term, we're left with 9. Now notice x squared minus 9 is a difference of 2 squares. So let's factor that. This is x squared minus 3 squared. So that factors as x plus 3 times x minus 3. In number 29, we do not have common factors. we have two terms, and we notice that both terms are perfect squares. So let's write this as something squared minus something squared. All right, so first the first term, the square root of 25 is 5. And for the square root of a power, just take half of the exponent, so that would be x cubed. All right, in the second term, the square root of 49 is 7. And for the square root of y to the 100, again, take half the exponent, so that would be y to the 50. So now we have the expression written as a difference of two squares, and we'll just use the difference of two squares formula. So in the first set of parentheses, we put 5x cubed plus 7y to the 50th. And in the second, 5x cubed minus 7y to the 50th. Okay, so that's factored. In number 30, we have a quadratic. All right, notice that 6x squared could be factored different ways. We could put 6xx or 3x2x. Let's just say we start with 3x2x. Also, c is less than 0, so we're going to put different signs. Now here we're going to put, in the last and last, we put two factors of 4. Now I'm not going to try 2 times 2. Let me just show you why in a minute here. I'll just write it in lightly. I'm not going to try 2 times 2 because then 2 would factor out of this second factor, but 2 doesn't factor out of our quadratic, so it can't possibly be 2 times 2. So let's try 4 times 1. For the same reason, I would not put a 4 here. So let's just try 4 times 1 over here. Middle term, we have 8x minus 3x. Okay, that does not add up to a plus 23. All right, so we're going to go with 6x and x. We're giving up on this. Again, different signs. Okay, so we can try 4 times 1 or 2 times 2. We're not going to go with 2 times 2 because if I put a 2 over here, it'll factor out. 2 will factor out from the first factor. So we're going to go with 4 times 1. And again, 4 can't go here for that same reason. So we'll try this for 1. All right, so that gives us x here. We're checking the middle term. And here we have minus 24x. This adds to minus 23x. And we have 23x, so we're going to switch signs to minus plus. And that'll be the correct factorization.